Hi, Assalamualaikum warahmatullahi wabarakatuh, my students. In chapter 11, we are going to learn lesson 82, chemical reactions of amine. The reactions we are going to learn is between amines and HCl, acyl chloride, benzene sulfonyl chloride, nitrous acid, and bromine water. The first reaction is reaction between primary amine with HCl. We are going to get an ammonium salt, but only one R is joining the salt. Secondary amine is going to have two R's, and tertiary amine is going to form a tertiary ammonium chloride salt whereby all the 3R is going to be attached to the nitrogen. Remember, nitrogen has one lone pair. Where does the lone pair go? It will form a covalent dative bond with hydrogen, H plus here, and H plus is bonded ionically with chlorine. So we have one covalent dative bond here between N and H, and one ionic bond here between hydrogen H plus and chlorine Cl minus. Example 11.6, you're going to do an equation between a primary amine with HCl. So we are going to form this primary ammonium chloride salt, whereby the R here is as a methyl group. It's going to be attached to the nitrogen in the ammonium chloride salt. The second example is a secondary amine. Here we have 2R, 2-methyl, and the 2-methyl is going to be attached to N, whereby N here is forming a secondary ammonium chloride salt. So when we have tertiary amine has 3R. So all of the 3R is going to be bonded with nitrogen, and this compound is called tertiary ammonium chloride salt. Okay, the second reaction is acylation. We've learned this reaction before when we were forming amines. As carboxylic acid, acyl chlorides are going to react with amines to form amine. Primary and secondary amines will be acylated to form N-substituted amines. Okay, this is the general reaction for the acylation of amine. For primary amine, we are going to produce this compound, whereby, as you can see, here is the amide bond. For secondary amine, all the R coming from amine is coming together with nitrogen, where nitrogen is attached to the carbonyl group from acyl chloride. So again, this is the amide bonding. Any R coming from acyl chloride is going to enter or bonded into the compound here. But one thing that you have to remember, if we have tertiary amine, it cannot be acylated because they don't have any free hydrogen bonded to its nitrogen. So the nitrogen atom, for example, this is NN-dimethyl methanamine, it doesn't have any free hydrogen to be used as a place where it is going to be bonded with the carbonyl carbon. So amide bond is not going to be produced here for tertiary amines only. For your example 11.7, you have to write an equation reaction between ethanamine and ethanoyl chloride. So firstly, you draw ethanamine. What classification of ethanamine? It is a primary amine. Yes, because it has two hydrogen attached to the nitrogen over here. So next, you have to draw ethanoyl chloride. Ethanoyl means it has two carbons. So draw two carbons where one is an R and another one is the carbonyl carbon. So you're going to attach the chloride directly to the carbonyl carbon. Now you're just going to cut the bond over here and cut it here between one of the hydrogen, and then you're going to combine it here to form a peptide bond. So you are basically forming an amide compound. Here is the reaction between N-methyl methanamine and propanoyl chloride. So draw the secondary amine here. Propanoyl chloride is like this, and you're going to get a new compound, amide, over here. The third reaction is reaction between amines and nitrous acid. Nitrous acid is an identification test to detect all 6 types of amine, because most of the observation is going to be different for all 6 categories. Okay, this slide I've done the Teams lecture with KSF1, so the notes are still here. I'm going to use it. HNO3 is a nitric acid, okay, but nitrous acid is a different acid. It's also a weak acid, same as nitric, but it is not as stable as nitric acid. Nitrous acid, or HN2, sometimes we call it HONO, Safaris would call it HONO, and we have to prepare it just before we want to use it by adding sodium nitrate and some sort of strong acid. For example, you can use HCl or sulfuric acid. Unfortunately, we are not able to run this experiment in the lab, but it's there in your textbook, in your laboratory book, in experiment 7. You can look at the methods, the materials and methods there. So we have to go one by one for every classes of amine. Primary aliphatic amine will produce firstly an unstable aliphatic diazonium salts, and then the salts will decompose. It will lose its nitrogen. It will form carbocation. Once it forms carbocation, it can form an alkene, a haloalkane, an alcohol. The observation for this reaction is bubbled gas produced. The N2 here is going to be eliminated when the carbocation is forming other products. So let's go through the general reaction. This is the primary amine. It is going to react with HONO. It's going to form diazonium salt, and this compound, this intermediate structure is not stable. It's going to form a carbocation by removing nitrogen gas. As it's going into stabilization, the carbocation lose one proton to become alkene, reacts with the aqueous environment in the solution to form alcohol, and also react with the chlorine coming from diazonium salt and also HCl to form a haloalkane. Let's do an example. Right, here is the example that you have to do in 11.8. It's a simple reaction, but it has 1, 2, 3, 4, 5 steps. It looks like complicated, but once we do it step by step, it's not going to be hard. The R here is a cyclopentyl. So I am drawing the cyclopentyl very small over here so that we can fit everything in one page. The CH2, CH2, NH2 is here. This is the primary amine, meaning that we need to have at least 2 carbons in the primary amine in order to react with nitrous acid. So this is the diazonium salt, the unstable intermediate structure, is going to form a carbocation, and carbocation here is going to form an alkene, an alcohol, and a haloalkane. Okay, and it's also going to produce or evolve a type of gas, nitrogen gas. Next is the reaction with secondary aliphatic amines. We are going to form nitrosamine. A nitrosamine is a yellow oil. So the observation when secondary aliphatic amines react with nitrous acid is the production of yellow oil. What we have here is only one step reaction, so it's going to be a simple example. 11.9, where we have N-methylethanamine reacts with nitrous acid. We are forming a nitrosoamine. Here is the R attached to the N from amine, and this N is attached directly to the N double bond O, which comes from the nitrous acid. And the observation is you have to write yellow oil is observed. The third reaction is using tertiary aliphatic amines, and we are forming a salt. So this water-soluble salt will give a clear solution. The observation will be simply a clear solution formed. So that particular compound is called nitrosoammonium ion. Here is the general reaction. So let's look at the example. Example 11.10. Let's look at the reactant here. CH2 and CH3, and we have 3R there. We reacted with, I have to do it like this because I am taking so much space there because I draw it so big. Okay, cold. We have to add cold over there. We're going to get N, attach all the R to our poor N over here. So many things attached to you. And then this N is going to have H plus Cl minus attached to it. And another product would be R3N plus N double bond O Cl minus. So the observation here is a water soluble salt will be produced, where you can also write a clear solution will be formed. We have finished with 3 aliphatic amines. Now we start with aromatic amines. Number 1, primary aromatic amine. When it reacts with HONO, it's going to form arine disonium salts. This is how it looks like. Okay, there is only one reaction between primary aromatic amine is an aniline, is going to form benzene disonium chloride. Secondary aromatic amine, when it reacts with HONO, it's going to form nitrosamine as well. Basically, this is the same observation and product with the ones that we had for secondary aliphatic amine. It's going to form nitrosamine, and the observation would be yellow oil produced. Let's look at example 11.11. Given to you is a secondary aromatic amine reacting with nitrous acid. It's going to form this product, which is going to give a yellow oil disperse. Now, tertiary aromatic amines is going to give a unique product when reacts with nitrous acid. It's going to form a yellow precipitate, which is a compound called nitrosoaniline. It has a substitution reaction happen at the para position. So that is what and why it is special. Here is example 11.12. Given to you is a tertiary aromatic amine where we have 1,2-methyl and a benzene ring attached to N. So this is an aniline. React with nitrous acid, and we're going to form this compound where, as you can see, 1, 2, 3, 4, the para position has a substitution of N double bond O. This compound is a yellow precipitate solid. Shown to you in table 11.3 is the summary and list of observations that we got from the reactions between 6 classes of amine with nitrous acid. Please do question number 5 in tutorial 11. Okay, the fourth reaction for amine is the reaction with bromine water. Bromine water is Br2 liquid. The environment is aqueous. It has to have H2O. So like phenol, aniline reacts with aqueous bromine, meaning that Br2 liquid plus H2O, we have aqueous bromine. Br2 liquid only is called bromine water. But Br2 liquid plus H2O is called aqueous bromine solution. The formation of white precipitate happens when we do this reaction, whereby amino group being an activating autopara director, it is going to put the bromine at the position of 2, 4, and 6. as shown to you here in your page 372. The name for this compound formed is 2,4,6-tribromoaniline. The last one that we're going to learn is Hinsberg's test. Nitrous acid, bromine water, and now benzene sulfonyl chlorides are all the reagents to test different classes of amine. So we are going to use benzene sulfonyl chlorides on primary and secondary amine in order to detect whether they are different from each other. They are going to form sulfonamide. But tertiary amine will not react. So we're going to know straight away which one is primary, which one is secondary, and which one is tertiary. Hinsberg test is the test to look at the formation of sulfonamide. For primary amine, we are going to form N-substituted benzene sulfonamide, where we are going to do the reaction based on acid-base reaction. First, we are going to use excess potassium hydroxide, and then we're going to use hydrochloric acid. So the observation is going to be very unique here, where firstly, when we do a reaction between primary amine and Hinsberg's reagent, we are going to form a precipitate. The precipitate is sulfonamide. Once we do the reaction, that precipitate will become soluble because the environment of the reagent is potassium hydroxide. It is a base. So it's going to form a water-soluble salt. Now we want to test this salt, whether it is a primary or secondary amine, coming from which amine. So we want to test it. We put in hydrochloric acid, the acidic environment, then it will form a precipitate or insoluble salt. So we know the observation, the first stage is going to become a clear solution. The second stage, when we add acid, is going to be a precipitate. For secondary amines, the observation would be different. So it is going to form an insoluble sulfonamide after we dissolve it with HCl. So as you can see here, this is the secondary amine. This is the Hinsberg reagent. And as we react it with the base environment, is going to form a precipitation. But when we add acidic environment, there would be no change. There would be no change in terms of the precipitation of sulfonamide is going to stay as it is. So the first observation is precipitation occur. The second observation is precipitate remains. This is the difference between secondary and primary amine. Lastly, for tertiary amine, we know that the structure of tertiary amine itself doesn't have any free hydrogen to make way for nitrogen to be bonded with anything. So what we're going to have is no reaction occur when we react it with Hinsberg reagent or benzene sulfonyl chloride. what we're going to have is a water-soluble salt. So we're going to get a clear solution. So this is the observation for tertiary amine when it is reacted with Hinsberg test. There's no reaction, but there is an observation for the no reaction, which is a clear solution formed or remains. This is the summary for Hinsberg's test. As you can see, primary amine, at the beginning, it will form a clear solution because the precipitate actually dissolve in the base that we use. And then as we put in acid, the precipitate formed. And then for secondary amine, precipitate occur at the beginning and it will not dilute in any acid. For tertiary amine, there would be no change. So we're going to see a water soluble salt in clear solution. It's going to be a clear solution observed there. So this is a test to identify between primary, secondary, and tertiary amine. Right. This is tutorial in your page 387, question number 10. So there's a few observation given, and all you have to do is just think of what is the type of amine that the reactant is. Because we only give you the observation. You have to think about a possible structure for the reactant because we're going to combine here between Hinsberg test and nitrous acid test. Okay, you can use any of the three tests to differentiate between these two compounds. So select which one you like, and you've done question number 11 at the same page. We have finished lesson 82. We hope that you will be able to understand everything that we're trying to give you by referring to the course book, the examples, the tutorial questions. As you notice in chapter 11, we don't have practices. We do practices by using the examples and also the tutorial questions only because we are already at the end of the semester and we only have one lesson to go. I hope you will be able to revise all the organic chapters in preparation for the final exam. I thank you very much for watching and listening to me. I'll see you again soon. Assalamualaikum warahmatullahi wabarakatuh. Madam Ruby logging off.